Hello everyone. Today we shall discuss about units and measurement of class 11. You see here how we are going to discuss about this one. That is, we are going to discuss the first thing, that is units and measurement. In units and measurement, what we will find here, that this is the universal law of gravitation. You see here, this is the universal law of gravitation, and you can see that universal law of gravitation can be represented by this formula. What is that? Actually, if there are two point masses, this is point masses m1, this is point mass m2, and the point masses are separated by distance r, small r. The universal gravitational force, this force is directly proportional to the product of the masses, that is m1 into m2. This is equation 1. According to universal law of gravitation, and we find that F is also directly proportional to 1 by r square, or square of the distance between the two point masses. Now you can see here that if we combine these two equations, equation 1 and 2, F is directly proportional to m1 into m2 by r square, right? And if you combine these two equations, we are getting this value, right? Now if we combine this equation, we are getting F equal to m upon m2 by r square. And if we combine, then we are getting this one. And you see here that by combining together, these are proportional, and if we remove this proportional by equal to, there is a constant of proportionality that is known as capital G. And this is m1 m2 by r square. In this way, the universal law of gravitation can be explained, and we know that the value of capital G is a constant, the capital G is fixed, and the value of capital G is 6.67 into 10 to the power minus 11 10 to the power minus 11 Newton meter square per kg square. This is the value of capital G, right? So the universal language of physics, how scientists tame chaos and describe the universe with a shared system of measurement. Therefore, F can be written as capital G m1 m2 pi r square. This is the universal law of gravitation. This is the universal law of gravitation. Now you can see here another thing. This is the universal language of physics. Now we see here, there are other things we can explain here also. That is a world of confusion, the scientific Tower of Babel. In the past, scientists across the globe used different systems of measurement. This created a landscape of confusion, hindering collaboration and progress. In experiments, results in one country were often difficult to replicate or even understand in another. We have three systems. One is Cbse system, FPS system, and MK system. In Cbse system, we can find that the distance is measured in terms of centimeter. Length is measured in terms of centimeter, and weight, mass is measured in terms of gram. Mass is measured in terms of grams, and time is measured in terms of second. Time is measured in terms of second. In this way, you can find there is FPS system also. Length is measured in terms of foot, mass is measured in terms of pound, and time is measured in terms of second. In Ncert system, length is measured in terms of meter, mass is measured in terms of kilogram, and time is measured in terms of second. Time is measured in terms of second. This is a world of confusion. So we have found what we found, that the Cbse system, the length is measured in centimeter, and mass is measured in gram, and time is measured in second. These are the few things we have to learn in measurement. So we have Cbse system, we have FPS system, we have MK system. These three systems you have to remember. Besides that, you will find that forging a common tongue for science. What is that? To solve this, the global scientific community developed the system of international unities, SI, or the International System of Units. First established in 1971 and recently revised in 2018, it provides a complete and consistent scheme of units for all scientific, technical, industrial, and commercial work. Key authority developed by the Bureau International des Points and Measures, the International Bureau of Weights and Measures, BIPM. Core advantage: because SI units use the decimal system, conversion within the system are quite simple and convenient also. Simple and convenient also. Now we see the other factors also. You see the other factors, that is the alphabet of reality. The 7 SI base unit. Just like the alphabet, a small set of fundamental units can be combined to describe nearly everything in the physical world. These are the 7 base units of the SI system. Number one, what we call is the length. Length is measured in meter. Length is measured in meter. And mass can be measured in kilogram. Time is measured in second. Electric current is measured in ampere. Ampere. Temperature is measured in Kelvin. Thermic temperature is measured also in Kelvin. An amount of substance is mole, and there is another luminous intensity, that is candela, right? So 1, 2, 3, 4, 5, 6 and 7, right? So there are 7 fundamental units. How many? There are 7 fundamental units. 7 fundamental units in SI system. 7 fundamental units in SI system. Beside the 7 fundamental system, there are 2 secondary systems also. And what are the 2 secondary systems? That I am going to reveal now. In the next one, what we want to learn, these are the systems, right? From human artifacts, now, beside these 7 fundamental system, there are 2 secondary system also. Two supplementary, there are 2 supplementary secondary units also. There are 2 supplementary unit also. So what we learn, that in SI there are 7 basic system, that is length is measured in meter, mass is measured in kilogram, time is measured in second, ampere current is measured in ampere, temperature is measured in Kelvin, and amount of substance is measured in mole, and luminous intensity is measured in candela or CD. These are the 7 fundamental units of physical measurement or in SI system. In SI system there are 2 supplementary units also. The first one is called as plane angle. This is plane angle, and plane angle can be measured in this way. Suppose this is A, this is B, ABC, A, B, C. This is the plane angle theta, and plane angle is measured by arc by radius. Suppose this is a circle, then this arc AC by radius, that is the angle theta, and theta can be written as arc AC, arc AC is this arc, this length, divided by radius, that is known as angle. And this angle can be measured in radian. Radian is the SI unit of angle measurement. This is known as radian. And you see here there is another thing, that is number 2 is solid angle. In solid angle, what do you find? In solid angle we get 2 things, that is this one. In solid angle, if it is a sphere, you take a part of this area, this is R, then the solid angle can be measured in steradian, that is d sigma is equal to dA, this area, by R square, and the measurement of this solid angle is in steradian. So what you find, that there are 7 fundamental SI unit and 2 supplementary units. Supplementary units are plane angle and solid angle. So plane angle can be measured in radian and solid angle can be measured in steradian. These are 2 basic important things we should learn. Now we will go to the next session and see what is given here. You see here, this is from human artifacts up to universal constant, from universal artifacts to universal constants. In a landmark 2018 revision, the definitions of the SI base units were revolutionized. They are no longer based on physical artifacts but are instead defined by fixing the numerical values of fundamental constants of nature, the ultimate source of truth. This ensures our system of measurement is stable, universal, and will never change. This is a physical artifact. These are fundamental constants. Meter, speed of light. Kilogram, Planck's constant. Seconds, cesium frequency. These are the various things we can understand. Here you see ampere, elementary charge. Kelvin, Boltzmann constant. Mole, Avogadro constant. These are related with these physical artifact with fundamental constant. Meter, speed of light. Kilogram, Planck constant. Second, cesium frequency. Ampere, elementary charge. Kelvin, Boltzmann constant. And mole, Avogadro constant. These are the few facts we should know. Now, next what we know, building a vocabulary, the derived units. By combining the 7 base units of our alphabet, we can form words to describe any other physical quantity. These are called derived units. That means from fundamental unit, we can find the derived units also. There are two types of units. One is fundamental units, and number 2 is derived units. What is the difference between them? If you remember that fundamental units are independent of each other. Suppose length, mass, time, these are fundamental units. And derived units are dependent on fundamental units. These are dependent on fundamental units. Derived units are dependent on fundamental units. You see, suppose area. Area is actually a derived unit because it is dependent on the length. And length is the unit of fundamental unit. So area is length into length in meter square. Therefore, area is a derived unit. Not only that, you see, suppose volume, velocity. Velocity equal to length by time. Length is the fundamental unit of fundamental unit. Time is also fundamental unit. But velocity is a derived unit because it is dependent on the fundamental units. This is derived unit. And now force. Force is equal to, you know that F equal to mass into acceleration. F equal to mass into acceleration. So it's the mass and acceleration. Therefore, force is a derived unit. That means what we can say that derived units are dependent on fundamental unit. And fundamental units are independent unit. Right? And derived units can be derived with the help of fundamental units. These are fundamental units, length are fundamental units, time is fundamental unit, that means area, velocity, force. These are all derived units. These are all derived units. Right? Now we'll go to the next session, that is this one. The grammar of reality, dimensional analysis. Every physical quantity has a dimension based on the 7 base quantities. It is represented, if it is mass, it is represented by capital M. If it is length, it is represented by length, capital L, time by capital T, etc. Dimensional analysis is the set of rules that ensures our scientific sentences, our equations are logical and consistent. What is the golden rule? The principle of homogeneity of dimension. This is the golden rule. A physical equation is valid only if the dimensions of all the terms are the same. You can only add or subtract quantities that are the same dimension. You cannot add length to time. Just you cannot add apples to oranges. This is the principle of homogeneity. So F equal to ma. For F we know the dimension is m l to the minus 2, and for m into m is m. L is m, L to the minus 2. So the dimensions of left hand side is equal to the dimension of right hand side. Example dimensional formula. Velocity V, L to the minus 1. Force M to the minus 2. Density M, L to the minus 3. These way you have to find the dimension of any quantity. Besides that, we'll go to the next section, that is this one. Checking Checking our sentences for consistency. Is the following equation for motion and dimensionally correct? We can check it also. X equal x0 plus b0 t plus half a t square. You know this is the equation of motion. X is the length. You know that x is the dimension of x is length. The dimension of x is length. X0 also length. V0 t L t to the minus 1 by t, that is also L, and half a t square L t to the minus 2 t square is also L. Note the constant half is dimensionless. Half has no dimension. It is dimensionless. Since every term has a dimension of length L, the equation is dimensionally consistent. Therefore, we can say that this formula is correct. If the dimension of left hand side and the dimension of right hand side is equal, then you can say that the equation is correct. Now we'll go to the next session, that is this one. This one, punctuation and style, communicating with precision. Beyond being grammatically correct, scientific language must be precise. It must honestly communicate the certainty of our knowledge. This is the role of significant figures. This is very much important in our life, that is significant figures. Significance is this one, that is these two figures are reliable, but these two is uncertain. This measurement has three significant figures, 1, 2, 3, right? Significant figures in a measured value include all the digits that are known reliably plus the first digit that is uncertain. So you have to learn all these things, right? That is punctuation, style, communicating with precision. Beyond being grammatically correct, scientific language must be precise. It must honestly communicate the certainty of our knowledge. This is the role of significant figures. Significant figures in a measured value include all the digits that are known reliably plus the first digit that is uncertain. Now we go to the next session. So you see here that punctuation and style, communicating with precision. Now we'll go to the next session, that is this one. That is the rules of scientific style in Garamount Premiere Pro display. A simple rule of thumb. A choice of different units does not change the number of significant figures in measurement. This 2.308 centimeter or 0.02308 meter and 23.08 millimeter all have four significant figures. So if you know what is the rule to find the significant figures. You see here, key rules for counting. Non-zero digits are always significant. You have to remember that non-zero digits are always significant. Zeros between non-zero digits are significant. Zeros between non-zero, this is non-zero. And the zeros between them are significant. That means there are four significant figures here, right? Number 3, trailing zeros after a decimal point are significant. You see here, that is 3.500. These 00s, the digits 3500 are highlighted. Trailing zeros after decimal point are significant. This is also significant. There is the four significant figures. Leading zeros, leading zeros in numbers less than 1 are not significant. Leading zeros in numbers less than 1 not significant. That only the digits 4, 5 are highlighted. These are not significant figures, right? So these are significant figures, but these are not significant. Leading zeros in numbers less than 1 are not significant. So the significant figures is these zeros are not significant figures. The ultimate tool for clarity, scientific notation. To remove all ambiguity with trailing zeros, report measurements in scientific notation. You have to write in scientific notation a into 10 power b. All digits in the base number a are significant. You see, for example, 48700 millimeter. We can write here in and significant figures 4.700 in 10 power 3 millimeter. Therefore, they are called as significant figures. Therefore, there are four significant. So you have to write it in scientific notation, and you got it in scientific notation, and you got it as significant figures, right? In this way, you can write all the numbers, right? So if we write the number in scientific notation, we will get the significant figures, right? Now we'll go to the another section, that is this one. Performing honest arithmetic. Performing honest arithmetic. For the result of a calculation cannot be more precise than the least precise measurement used to obtain it. For multiplication or division, this is the rule for multiplication or division. What is that? You see here that the final result should retain as many significant figures as the original number with the least number of significant figures. You see here there are 3 significant figures, there are 4 significant figures, but the answer should be in 3 significant figures, right? The least one. There is 1.688 gram per cubic centimeter, there is 1.69 gram per cubic centimeter. This is rounded to 3 significant figures, and this will be the answers. That if you divide, you have to take the least significant figures. For addition or subtraction, the final result should retain as many decimal places as the number with the least number of decimal places. 436.32, 227.2, 0.003, 301, and you get 8 to 1. But here this one is least. So you have to take the answer after one decimal point, 663.8 gram. So because 227.2 has the least one decimal place. This has one decimal place. So the answer should be one decimal place in case of addition or subtraction. But in case of multiplication and division, you have to take the least significant figures, that is 3 significant figures. 3 or whatever may be the least significant figure, that you have to take the answer. Right? In this way, we will find the least significant figures. Besides that, we will get here other important things, that is this one. Speaking physics fluently, deducing new relationship. Problem. Consider a simple pendulum. We hypothesize that its period of oscillation t depends on the length of the string and mass of the bob and acceleration due to gravity. Can you find the relationship? Yes, we can find. By the approach of dimension analysis, we can find the relation, but you have to know what are the dependent factors for simple pendulum. You see here, assume a relationship t is equal to k x to the power k l to the power x into g to the power y dm to the power z, right? Equate the equations on both sides. That is, this is the dimension of t to the power 1. This is the dimension of this one, that is l to the power x, g l to the power minus 2y, name mass z, right? And simplify and group dimension m0 l0 t1 mz lx plus y t to the power minus 2y. If we equate this with that, z equal to 0, x plus y equal to 0, and minus 2y equal to 1, right? Minus 2y equal to 1. With this, we are getting two values, x equal to 1 by 2 and y equal to minus 1 by 2. The result, dimension analysis reveals the form of the equation. Substituting the exponents back in this, what we get that kt is equal to k l to the power half and g to the power minus half, right? And what we get that t is equal to k root over l by g, right? The dimensionless constant k, which is 2 pi, cannot be found this way. We have derived the relationship with a single experiment. Without experiment, we cannot find the value of k, right? So this is which is 2 pi, the dimensional constant k, which is 2 pi, cannot be found in this way, but we have to derive the relationship with a single experiment. So we can say that with the dimensional analysis, we can find the relationship also. This formula you can find out with the help of dimensional analysis. Now going to the next one, what we get, you see here. This one is the language of discovery. By mastering these fundamental components, we move from simply stating facts to speaking the language of physics. This is the system that underpins all of scientific discovery and communication. The alphabets, base units, right? These are the alphabets of base unit. That is, you find here the length is measured. We have already discussed this one. Length is measured in meter. Mass is measured in kilogram. Time is measured in second. Temperature is measured in Kelvin. Light is measured in luminous intensity is measured in candela. Amount of substance is measured in mole. Electric current is measured in ampere, and temperature is measured in Kelvin. And this is the thermodynamic scale. This is the base units. Grammar, dimensional analysis. If the left hand side is equal to the right hand side, then it is grammatically correct. This type, significant figures, you already learned the significant figures. For discovery understanding, to write the exact significant figures, you have to take it the scientific notation. Only then you can find the significant figures. In this way, you can do all the things. Show the shared blueprint of the universe. The international system of units, with its rules of grammar and style, is more than a tool. It is the shared language that allows humanity across borders, cultures, and generations to read, write, and collaboratively understand the blueprint of the universe. So, we have learned the basic things of units of measurement. So we learned the basic things of units and measurements. Dear friends, if you like this video, please subscribe, like and share. Thank you everybody for watching this video. Thank you.